Okay, so I'm working on the eBay. I'm gonna give a talk about the e-commerce marketing modeling, but don't assume I'm using eBay data. So, and actually, I have been sitting here for the conference yesterday and the whole morning of today, and I have seen a lot of speakers give wonderful talk, and many of them have very good, title like a head of data science, and they give very high level of data insight or the development of data science. And so yesterday, actually, I was thinking maybe I can, modify my presentation a little bit to give you a more like a practical guidance for what we really do in industry, like how we really apply machine learning algorithm to build a model, and also consequently to achieve some business success. And this is my purpose. And for some professional data scientists, it may be a little too basic, but for new people and students, this may be a practical guidance. Okay, so let me start it. Okay, yeah. So the outline will be, so first I will give you some background, and then the methodology, that how we build this model from starting point, and then we will explore the data and generate some insights, and I'll share these insights with you, and also the model building and the testing, and finally we will automate this model to our real business. Okay, so in e-commerce industry, the revenue generation basically come from 4 major parts. So the first one is called final value fee, FVF, which means that, for example, if you you want to sell some stuff, say on eBay or Amazon or Taobao, and then if you sell like $100, you will be charged like $10 by the website, by the e-commerce company, and this $10 is called final value fee. Of course, different company has different discount, 10%, 15% is all different. And this is the major revenue sources for the e-commerce company. And this is the first one, and the second one is the listing fee. For example, if you want to sell some stuff, you need to list it on the website. And the listing usually for the first few tens or hundred, it may be free, but if you list more, you need to pay for each listings. So another revenue generation from here. So third one is subscription. For example, like eBay or Amazon, they have some store product. If you are a big seller and you want to be a store seller, and then you need to pay some fee for that. For example, you pay monthly fee, say $100, then you do enjoy some benefit. I'll tell you later. And the fourth part is advertisement. If you are a new seller and no one knows what you are selling, no one knows your product, and you don't have a history and record in the database, so even the e-commerce company cannot promote you, but you can promote yourself, which means that you pay certain amount money, like say 1% of my total price, or 2%, so 2% some of them, and then you can advertise your store or your product on this website, like say eBay website or Amazon website. Yeah, and then you have some impressions for targeted audience, and then you will get more and more popular for your product. Okay, so here then we can easily to see the marketing strategy, because the eBay or Amazon, the store product can really bring the stable and the continuous and the larger revenue from the final value fee. And the things are, the store sellers will enjoy free listings. For example, if you are a non-store or normal sellers, you may have only 50 or 100 free listings per month. But if you subscribe as a store seller, you pay like say $100 per month, but you can list say maybe 2,000 free listings. So which is really a good benefit, financially benefit. As well, you enjoy some discount for final value fee. For example, the normal people, the non-store sellers, they pay 10%. And you may need to only pay like 8%, 7%, depending on different category. So this is also a good saving. And here, the marketing strategy is to try to acquire more store subscription from the non-store sellers. Yeah. And this is actually our target for this project. The current, actually, before we build this model, and the targeted marketing campaign has been run by the marketers. And they are very good business person. They have really good business insights to know what kind of segment people I want to be targeted. But that is very rough. It's not accurate targeting. And the result turned to be we have very low conversion rate. I can tell you it's only about 3-4% conversion. Which means, for example, we send out email campaign, 1,000 emails, there's only 30-40 reply back. Yeah, and a lot of emails just go to the junk mails. So the data science here is really helping for the marketing campaign because we can, using some modeling method to target the right audience very accurately and efficiently. And also, generate less spam emails. Okay, so here's a workflow to build the model. First step, we will need to explore the data and find out the strong predictors, features for both store and non-store sellers. And the second step, we need to profile those sellers by multiple features that we already obtained. And also, using these features, we extract data different, from the big database. Actually, e-commerce company has really big database. So you need to extract some records, and you need to use some sampling method. I'll talk about it later. So finally, you will have a data table built up, and then use this data table, you can build the prediction model to predict the likelihood of non-store sellers who is highly possible to be a store seller. And then the final final process is, we can productionalize this whole model and make it automatically updated each month. Okay, so now let's go to the detailed description of the model. The first step is the feature selection. We want to identify the likely features for seller profile and behavior. So if you look at the database, actually, you very rich data for each seller. For example, we know the basic information, say which country is he or she registered the store, what is the time, and also say some web view information, say the click information, impression information, and also some business behavior. For example, the listings, sold items, generalized the merchandise value, we call it GMV, which means the total money you sold. Yeah. And roughly we get about 100 raw data fields. That's really a lot. We actually, there are several feature selection methods using even machine learning algorithm. For example, a random forest or a feature score. But here, actually, we more trust our business insights. We have some domain knowledge and experience. So marketers and the data science team, we work together, and we finally identify, just manually pick up 29 features here. Okay, so first, the key features. We actually noticed that the listings behavior is really the key feature to drive the seller's propensity for store subscription. And because this is also potentially financial benefiting for the non-store sellers because they can enjoy a lot free listings from this store package. And there are also two correlated features, the sold item and the GMV. So if you have more listings, highly possible you will sell more. So the sold item will be correlated with listings. As well, if you sold more, you will sold more money. So the GMV, general less the merchandise value, is also correlated with sold items. When we build a model, we usually try to keep non-correlated factors. But here, I would prefer to keep all these factors in the model because they are so important. And if we, eliminate one of them, we lose really important information. Okay, so here actually I want to show some a quick insight for the listings. You can see this histogram of the listings, and it's highly skewed. And you can see there are much more people, like a very high frequency. The listings is distributed from 0 to 100. And actually, if we see the data, actually more people just list 1 or 2 listings in 1 month. This is 1 month data. And the same thing for sold item and the GMV as well. So here actually we can see there are a lot of people, they didn't list a lot, which means that if we target those people to give them offer or promotion and try to persuade them become to be a store seller, and then it's actually no use because they only list out sold very few items each month. And also from these three graphs, you can sort of have an idea they are really correlated together. Okay, so other than the king feature and the queen features, we have more features added up to the models. The other features, I can summarize them here, are, for example, the credit score of sellers. We usually mark each seller with different credit score, and there are several levels. But here in the model, we just use good credit or bad credit. We just don't, we neglect the middle level. Yeah, actually, good credit and bad credit are 2 features, and those are like a Boolean value, yes, no. And the second type are the listing types. For the listings, actually, there are 2 major types. And one is called fresh listing, which means you are the first time to list this item. Say I want to sold a speaker, okay? And first time to list it is called fresh listing. But after 7 days, I haven't sold yet. I can relist it without paying another time listing fee. So it's called relist. Different e-commerce company allow you to relist different times. Maybe you can relist 1 time or twice or 3 times, depends. Then shipping options. You can offer a free shipping for your buyers, or you can ask your buyer to pay for the shipping. And for shipping, you can also provide the shipping label. And that's good because actually usually the e-commerce website will provide some discount for shipping labels. And another factor is called word store, means that have you been a store before? Because some people they may register for a store last year and then they churn. And this year they decide to come back again. So word store is a very important factor as well. Safe means if you are really financially benefiting from store package. Think about this simple math. So for each list, so first month, firstly, in 1 month, you have, say, 50 free listings. And then after that, you have to pay certain amount money, maybe 30 cents for each listing, okay? And then if you list it more than 1,000, and you can sum up, the listing fee is kind of expensive. But if you are a store seller, within 1,000 listings, you can, get every listings free. And you pay $100 each month for store subscription fee. So this is actually a simple calculation to see if you register for a store, will you really get financially benefiting from it? And the save is actually a feature tell you how much money you save. Yeah, if you don't save, it's 0. If you save some money, it will tell you how much you save. And the last type of features are business type. You can identify yourself as B2C or C2C. Okay, so here's the full list of selected features. And the first two relisting and fresh listing I have explained. And from the second through seventh, there are listings. As I said, listings is a very important feature. So actually, I put the data from, say, we based on 1 month, and then I put the data for the past 6 months history for each month, how many listings this seller has listed. And then the sold item also for the past 6 months. Also the GMV, generalized merchandise value, also for the past 6 months. And then there are two features called count listing type or count category, which means that the count listing type is actually, say you have 100 listings, there may be 50 relisting, 50 fresh listings. And this count calculates your dominant listing type. See, if you have 60 fresh listing, 40 relisting, then this count will be 60, because 60, the fresh listing will be the dominant type. And then the count of category is the same thing. It's count of the dominant category your product falls into. It may be electronics or household, something. And then free shipping label, safe, I have talked about it earlier. Good credit, bad credit, word store, B2C, C2C. So there's all the features we use for our model. Actually, not a lot, especially compared with our data set. I used to, see some case like there is some medical care project, and they have more than 1,000 features, but only 500 records. So it's much more features than record. It's actually very hard to do modeling. It's like a huge overfitting issue, and they have to rank the features, select the important features. So it's totally different story. Okay, so now we identify the features, and then we should identify the data, how many data record we should use. For both new store and non-store sellers, we use summarized or say aggregated data. Because in the database, actually, furthermore, if you have one listing, and then you have one record in database. If you have one sold item, you have another record. So we have to aggregate them all together, and the final result will be one seller has only one record. It's aggregated. And this table will be updated each day because the seller's behavior change every day. And here actually we also get a byproduct. So we also build a really good data table including all these features, and we build a dashboard to show insights, and it's updated, daily updated dashboard, and which is our director really like it. So it seems like I'm working on one project but give 2 projects at the same time. Okay, and as I said, the data is really big, and we have to do sampling. Even though each seller finally has only one record, we still have millions record for non-store sellers. Think about the final data set. If we have labeled data like a new store seller, there's only 10K, but the non-store seller has millions. You cannot do anything with this data, right? So we have to sample these non-store sellers. From millions records, we finally get 10K. What we do is we do stratified sampling. So look at this chart I have shown you before. And because the number of listings is highly skewed, so we actually from each listing range, we do certain percent of sampling. So by this stratified sampling, we finally get 40K records from these millions records. And then right now the label 1 and the label 0 is 2280, means 10K versus 40K. But everyone knows that if the data set has half label 1 to 0, that will give you the best prediction result. And that's what we do as well. So from this 4K data, we finally somewhat, only get 10K non-store data. Now we have really clean data, and which is really make our next step modeling is much easier. Here I'm going to show you some a correlation. This is actually very interesting business insights. For the new store, which means that for this month they subscribe as a new store seller, and we can see listings. For the 6 months listings, they are highly correlated, of course, and for sold item as well, yes. And also here you see the count of listing type and count of category. These two also correlated. And actually here, it gives us very good insights, means that the new store sellers, let's put another way. So let's see, the count of listing type is not correlated with listings, right? And the count of category is also not correlated with listings. It actually means these new store sellers, they have very diversified listing type and a diversified category. And they may sell product, covering different category. And they may have, listing, fresh listing and the relisting ratio also very, very random. And this is interesting because if we see next one, the non-store correlation metrics, and we can see the count, also the 20 and the 21 count of, how to go back over here. So the count of listing type and the count of category, they are actually highly correlated with listings. If you see you can see that, right? So which means that for non-store sellers, they highly likely only focus on one single category, or they highly likely only have one type of, either relisting or fresh listings. And also, if you see the relisting, the number 0, the very first one, this relisting is also correlated with listings. This is different than the new store. In new store, the relisting doesn't correlate with listings, which means that the non-store sellers actually their selling behavior is not so good. They have to release their product many times. So, if they become to be a store seller, that may give them the benefit. They don't need to release a lot of times. Okay, so now we have really good data, and then we start to build a model. And some, some students or new people may think about the model building may be more complicated, but actually, in practice, the model building part is much easier than the data preparation. And we use multivariate profiles and the different machine learning algorithms and to model this. And we implement it by SQL, and the SQL here is basically to just extract data from database. And the whole machine learning modeling was built by Python and using the popular package pandas and the scikit-learn. And because we have less features and more records, so we don't have the overfitting issue. And the machine learning algorithm here I use is because this is a classification issue. So we use support vector machine, logistic regression, decision tree was as well, random forest, KNN, naive Bayes. Yeah, that's all we use. And the for validation part, we did 2 types. One is we split the train test site 70-30 and the cross validation tenfold. And now here is the result. Let's do some comparison. For model fit and F1 score, this is the test result. We can see for logistic regression, it's sort of the same, 0.89. For support vector machine, it's interesting. So the model fits very well, but actually when we test it, it gives us very poor F1 score. For decision tree, it's really good performance. So it's close to 1 model fit and 0.96 for testing. KNN 0.94 versus 0.91. Bayes is not so good, it's 0.8, around 0.8. And the best one here we use is random forest. It's actually very close to decision tree though. So we fit the model very well, 0.99. And the test result, advanced score is 0.97. This is the best. So in practice, we use this model. And for application, we applied this model to a new data set, and we almost get 90% conversion based on the model forecast. Think about our old conversion is only 3%. This is really big beat. And the final step is model automation. Yeah, so before our data science team usually just build model and implement it once, that's all. And next time if we wanna do it again, we have to run data another time, and we have to extract the updated data again and to adjust the model parameters and do the forecast again. So that's a lot of manual work and repeated work. And this actually model automation part, actually I generated this idea from my previous experience in hedge fund. So think about the trading system. It's actually every second they will be updated. There are a lot of models and the data will be updated. So for this model implementation automation, we use aggregated data and we keep it daily update. And for each month, we will update the whole model. And this whole thing will be realized in the Python, inside Python learning machine. So every month, we just need to click run. It will automatically give us the forecast result, which is much easier for us. Okay, so that's the whole model building process. And thank you very much. And any questions are welcome.